Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 29 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Kepler kit for Raspberry Pi Pico W. Now, most of you guys probably already have your kit, but if you don't, look down in the description. There is a link over to Amazon. You can hop on over there and get your kit. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's talk about what I am going to teach you today. And it's really a very exciting lesson, and it's actually the homework assignment to the homework that I gave you in lesson number 28. So I must ask, how many of you guys were successful on your own getting the homework done? If you were successful, leave a comment down below. I am legend. Double chest bump. And if you were not, leave a comment down below. I folded up like a cheap Walmart lawn chair. And hey, I appreciate you guys that are posting your homework to YouTube and then linking over to this video and then leaving a link down below in the comments over to your video. I look at every single homework that you guys post, and I really love looking at it. I love to see the different strategies and approaches that different people take to solving these homework assignments. So I look at every single homework assignment that is posted to my channel. Okay, so what was the homework assignment that we will be looking at this week? What the homework assignment was to create a simple client-server project where you control an RGB LED on your Raspberry Pi Pico W over Wi-Fi from your PC. So we will be communicating over Wi-Fi, and from our PC, we will be able to control what's going on the Raspberry Pi Pico W. Now you see that I also want to display some useful information because this is going to be operated remotely. So I put the little OLED display, and then I've got the RGB LED. Let's take a quick second and let's look at that. Let's take a quick second and let me show you that schematic. Now I want to remind you that I think it was lesson, what was it? Lesson number 25. Give me just a second. I think it was lesson number 25 where I actually went in. I've got to look over here. Give me just a second. I think it was lesson number 25 where I went in and I showed you how to do the OLED, and everything that you needed to know about the OLED was in lesson number 25 in this series. And then also in earlier lessons, we used the RGB LED. And so today we're taking those two things that we already knew and then we're applying what we learned last week, which was how to communicate over Wi-Fi. Okay, so we're going to bring all that stuff that we've done in the past together for a project, an interesting project. So let's look at this. How do we hook this up? Well, I've got the Raspberry Pi Pico W, and then from pin number 3 up here, I establish a ground rail. Okay, and then that ground rail comes all the way across. And then down here from, it looks like pin 36, which is the 5th pin over, I establish a power rail. And then that power rail comes across, I jumper that up here. So I've got a power rail up here, and I've got a power rail down here, and that will be at 3.3 volts. Okay, hooking up the 1306 is pretty easy. I've got the SDA pin hooked up to pin 4, which is the SDA pin on the Raspberry Pi Pico W, and then to pin 5, 1, 2, 3, 4, 5, which is GPIO pin 3, I have got SCK. So I've got SCK to SCK and SDA to SDA as such. Then over here, I've got the RGB LED. This is the long leg. I've got the long leg connected to the ground rail. And then when you have the long leg in this position, then to the left, this leg will be the R channel, the green channel here, and the blue channel here. So R, ground, GB. I go through 220 ohm resistors, and the red channel is connected to GPIO pin 16. The green channel is connected to GPIO pin 17, and the blue channel is connected to GPIO pin 18 over here, GPIO pin 18. Okay, so that all looks good, and that should just be pretty straightforward for you to hook up. So I think that we're actually ready to come over here and to start coding. So most of the work is going to be on the server side. It's going to be on the Raspberry Pi Pico W. And so we're going to start there. And I've got kind of two views. This is going to be my Thonny for talking to the Raspberry Pi Pico W. And then this is going to be the server side. And then this is going to be the client side. But I'm going to show the windows side by side so you can kind of see the code for the client right next to the code for the server. And so let me come over here now. I think we are ready to come over here and actually start coding. So this again is the server side, and you can come down here. I'm actually going to make sure that I am connected to the Raspberry Pi Pico W, and then I think I should go ahead and save this. I'll save this as my Pico RGB.pi, my Pico RGB. I should probably say server.py, something like that that's descriptive. Okay. Now we've got that. Now, in order to talk over Wi-Fi, in order to connect over Wi-Fi, because we're creating a client-server relationship. In order to talk over Wi-Fi, the first thing I need to do is import socket. And I'm going to go a little faster this time because last week I showed you how to set up a client and a server, how to set up the server on the Raspberry Pi Pico W, and how to set up the client on your desktop PC. So I talked about that last week, and so this time I'm going to be going a little bit faster. Now we usually need to put delays in, so I'm going to import time like that, and then when we connect, we're going to have to talk over the network, so I'm going to need to import network like that. Now, I don't want to show you in my program my Wi-Fi credentials, and so I've saved them in a little file called secrets, and I'll just import secrets. You don't need to do this because you don't have a secrets file. You can just type your password and Wi-Fi name in a minute, but I have to do it this way so I don't expose it to the whole world. So bottom line, you do not need and should not import secrets. Now we're also going to be working with the GPIO pin, so I need to import machine like that. Now let's go ahead and let's set up that OLED 1306 display. So from machine, I need to import pin because we're going to be working with the GPIO pins, and we're talking to the OLED over I2C, so I need to import I2C like that. Okay, and those come from machine. Now from my OLED library, which is SSD 1306, I need to import, and I see that I did not spell import up here right. Doesn't count as a mistake if you correct it before you run it. This is going to be SSD 1306 underscore I2C. So I need to import this I2C library from the SSD 1306 library. Okay, I think those are the libraries I need. Let's go ahead and hook up. Let's go ahead and get this RGB LED set up. And so I'm going to have my red LED pin, and remember that was connected to GPIO pin 16. I have the green LED pin, and that is going to be connected to pin 17, GPIO pin 17, and blue LED pin is going to be connected to pin 18, GPIO pin 18. And I showed you that in the schematic, and I showed that to you live. So you should sort of understand that at that point. Now let's go ahead and set up those pins by creating our LED objects. So I'm going to have a red LED object, and that is going to be the method pin. And what pin is that? That's the red LED pin. And what's it going to be, an input or an output? It is going to be an output like that. Make sure you get your case right. If you don't get your case perfectly, it's not going to work. Now we're going to go green LED, and that is going to be pin, and then that is green LED pin, and then pin dot out like that. And one more, blue LED is equal to pin, and now blue LED pin, that's the pin, and that pin we want to be an output pin like that. Okay, now what I like to do, because we got a lot going on here, we're setting up a Wi-Fi network, we're setting up a client, we're setting up a server, and then something doesn't work. It's very hard to debug. So right now I want to confirm that I have that LED connected and working right. And so what I'm going to do is I'm just going to go ahead and I'm going to say red LED dot value and set it to 1, okay, like that. So I just want to test and make sure that works. And so what I'll do is I will come over here and show you this view, and now I'm going to go ahead and run the program. And when I run the program, boom, it turns red. So that's good. And I'll come back over here to this view, and I'm going to go ahead and turn that off. And I'm going to leave these lines of code in here, but just start with them all off. And now I want to make sure that they're all working. So red, now I'm going to test the green LED, and I will set that to a value of 1. And then we'll come back over here and we will run that. And boom, it turns green. And now we have one more to do. We are going to come in, and I will I just copy this, copy, paste, and I will change this to blue like that, and then I'll turn the green off. And now let's see if that works. Let's see if we go blue. And this will basically just confirm that we are talking to, okay, good, that looks good, that we have the RGB LED connected upright, and we've got it coded upright, and we've got our pins right, and we've got good connections. So now we'll just go ahead and I will run it, and it will turn everything off. Okay, everything is off, and now we are ready to roll. We are ready to move on, and we know that that part really works. Now, if we're going to talk to the OLED, we need to go ahead and set that up, and so we're going to talk to it over I2C. So I'm going to create an I2C object, which is going to be equal to I2C, that library that we imported. And then what I need to do is I need to tell it which bus I am on. Well, remember I connected to GPIO pin 2 and GPIO pin 3. Those are on the I2C bus 1. So I've got to give it the bus number 1. All right. And now what I have to do is I've got to tell it that the SDA is equal to pin, GPIO pin 2, if you go according to my schematic, and then the SCL is equal to pin 3, like that. And then I got to give it a frequency, and we'll just set frequency is equal to 400,000. That's 4 with 5 zeros, 400,000. Close that call. And let's just check it. 1, got the SDA, got the SCL, got the pin, and got the frequency. Okay, now I've turned on. What did that just happen? Okay, I need to close that like that. There. Okay, so now that looks good. That's all good. So I've got the I2C bus set up. Now I've got to create a display object. I'm going to call that DSP. You can call yours whatever you want. And that is going to be that library SSD 1306 underscore I2C. And then our display is 128 wide by 64 pixels high, and we're talking to it over I2C, that bus that we just created. And so that looks good. That should be good. Okay, that should be good. Now, I think I want to go ahead and test that. So I'm just going to say dsp.text, and then I'm going to say, hello world, like that. And then I'm going to go to column 0, pixel 0, and then y value 0, like that. And let's see if there's anything else. I think that's all I have to do. That's all I have to do. And so I'll go like this. Okay, let's come back over here and let's see if we can talk to that OLED. Guys, if there's anything you learn on complicated builds like this in projects, test your code as you go. Let's make sure that we can talk to the OLED. Okay, we don't get any errors and nothing showed up. Why did it not? Man, this is the most annoying error, is you forget over here that you have to put in dsp.show. Okay, and I can't tell you how many hours I have wasted trying to find that silly little error. It's just I don't expect to have to put that in, and sometimes I don't, and so we don't get any errors. And boom, hello world. So our RGB LED is working, and we're talking to our display. We are moving right along here. Back to our code view, back to our server, and now I'm going to go ahead and I'll just comment that out. I like to leave it in there in case I need to come back and test it again in a minute. Okay, so now what did I do? What did I do? All right, now I've got the display working. So now what I'm ready to do is I need to create my Wi-Fi object, and that is going to be a network.wide WLAN. All right, and then I use network, okay, dot sta_if. So this is creating that Wi-Fi object that I am talking to. It's going to be a local area network type. And as I explained last week, you can dig into these parameters like this, but they're not very interesting and not really any exciting object, in any exciting options. And so if you just go on and do this, then it'll just be the simple thing that works. And then if you're really interested in this, you can go away and dig into it. But for me, this works, and this is pretty easy. So once I create that, I want to give it just a little bit of time to get that done. Sometimes if you do these things too fast, you can actually end up getting things locked up. And so just a good measure, put a little delay in there. Now I'm going to activate. So I'm going to say Wi-Fi active. I'm going to make it active by making it true like that. So now I've created my Wi-Fi object, and it is using that network library that I imported up here, and it's using the WLAN method, and then we're setting this parameter. Again, dig into that on your own if you're interested. I'm going to give it a little time to activate, so I'm going to go sleep. 0.5. You guys can play around with this. It might work without these delays, but I've just found it's good measure to do it. Now you want to connect to your router. Okay, you want to connect to your router. So you've got your Wi-Fi object, and now you're going to connect to that Wi-Fi object. Well, what do you have to do? You got to give it your router name, and you got to give it your password, and that's your Wi-Fi name, right? That's right. Let's see if I can come over. I'm trying to think. I don't have a good place to show you, but that's when you connect to Wi-Fi, and the little Wi-Fi thing comes up, and it has all the different Wi-Fi names for the Wi-Fi networks you can connect to. You need to type in exactly your Wi-Fi name, and so this might be PJM Office, might be my Wi-Fi name, and you put the Wi-Fi name in that single quote, and then you might say here your password inside of single quotes, so PJM PSSWD, something like that. Okay, so you see you put your Wi-Fi name in quotes and then comma your password in single quotes like that. That's what you need to do. But I don't want to show you my password, and so I saved it. I saved it into that secrets file, and so all I do is say Wi-Fi.connect. You don't do this because you put yours in the step before. It is secrets.ssid and then comma secrets.password like that. Okay, so that should allow me to connect. Okay, that should allow me to connect. You don't do this step, you do this step, and you use your router name and you use your password. All right, just like that. So that should be pretty good. Now I'm going to go ahead and do a count equals 0, right? Because I'm going to be doing a little counting. Now I want to actually log on, right? I want to actually wait for it to log on. So that command was to log on. Now the problem is you might put a half-second delay here, but what on a given particular day your router took 5 seconds or 3 seconds or 12 seconds to connect, then it's going to crash if you move on with more program before the connection is actually made. And so I want to put a little delay in here where we're going to pause until when? Until the connection has been established. So I'm going to say while Wi-Fi dot is connected, while Wi-Fi dot connected equal false. So that means as long as it hasn't connected yet, I'm just going to hang here. I'm going to say print. And I'm going to print waiting like that. Okay. And I'm also going to see if I can put it over on the OLED. So I'm going to say display text like that. And I'm going to put a dot. And I'm going to put waiting. And I'm going to put that at pixel row or pixel column 0 and row 0 like that. Okay, and now I'm going to display text and then the string value of count, and so that'll just show a little number incrementing showing you that the thing is still alive. So the string value of count, which is my counter I set up just a couple of seconds ago, and this is going to be the second line, so this is still column 0 on pixel, and in row I'm going to go to the next row, which would be like 16 pixels down. Okay, and so that is going to close the string. That is going to, I need to, that was one big silly thing that I did there. Okay, how about string of count? And then I close that. That looks good. Now I don't want to, now what I need to do is I need to remember to show it. So I'm going to say DSP show like that. And now I'm going to wait time.sleep of 1, time.sleep of 1. Okay. And now what I'm going to do is I am going to say count equal count plus 1, and now I want to clear the screen. I want to clear my buffer so that I'm not overriding text on itself. So I'm just going to do a DSP dot fill it with zeros. Fill it with zeros. So what's that going to do? That's just going to turn the display blank, and then I'll immediately write it again, and that way it's not writing on top of each other. I sort of clear off the old before I go to the new. Now, yeah, I think we're going to go ahead and try to run this. We're going to go ahead and try to run this and see if it will actually, what would we expect it to do? It should just sort of show a countdown at this point. So let's see if this would show us a countdown on the screen. And so we're going to come in and we are going to run it. Okay, and it doesn't like line 34. I did not put the end. Did not like line 34. What did I do? I didn't close the quote like that. And so now we'll come back over here and we are going to run it again and just see if we get something happening there. And it went blank and then it didn't do anything. Is connected. It didn't like is okay. Look at that. You see, you got to spell right here, connected. Connected. I actually like connected better, but we will go along. We will go ahead and use the conventional spelling here. So let's run this now that we have that done. And no error, nothing happening. So it's like we never got down in there, and but we didn't get an error. Okay, you know what I'm going to do here? Just because I've been playing around with it, sometimes when something like this happens, it's good to unplug it and just plug it in again. Okay, and now we're plugged in. We powered off and we plugged in. Now I'm going to come over and I'll make sure that I'm connected here. Okay, nothing else is connected to it. It is connected. And now I'm going to run it again. And still it is not showing anything. So it's like it's not connecting. Okay. Boom. Look at that. Waiting 1, 2. Okay, and then it stops waiting, and so that means that it actually got connected. Okay, good. That is exactly what we wanted to see. Okay, so you saw me very confused about why that wasn't working. It could be that it had a connection from me running a program before or getting ready for this, and so sometimes if it's a completely unexpected behavior, a good place to start would be to start with just powering off and powering back on. Okay, so that looks good. Let's come back over to the code, and now you see that it still did leave on the screen. It left this. Now we want to go ahead and clear that after we leave. It left that on there. We want to clear that off of there after we leave this. So I'm going to come here and just do a dsp.fill 0 like that, just to make sure that we're starting with a clean display after we come out of that thing. Okay, does that make sense? I hope that makes sense. Okay, now what I need to do is I need to actually go out and get my IP address. So I'm going to say Wi-Fi info is equal to Wi-Fi, the object that I created and is now connected, and I need to do ifconfig like that. Okay, and then that should give me my Wi-Fi IP address. So let's try that. I'm just going to now say print Wi-Fi info like that, and let's see if we get that. Okay, there it is. Boom. So you see, I can see here, this is my IP address for the Raspberry Pi Pico W. Now, as I said in last week's lesson, this would be an excellent time for you to log on to your router and now reserve this IP address for your Raspberry Pi Pico 0 and Pico W, because that way, every time you run the program, it'll have the same IP address. Otherwise, if you reboot or something like that, you might get a different IP address. So you can make this static. I can't show you how to do that because there's a million different routers. Just look up your router. If you don't know how to do it, Google your router with the keywords static IP address. Okay. So, or if you have trouble with that, just every time check your IP address and make sure on the client side that you're referencing the right IP address. But you can see that there's also like gateway, there's also like your gateway IP address, and then there's also the IP address of your router and different things like that. So what do you really want? You really want the first one of those, okay? You really want the first one of those. And then, so what I am going to do is, I also think I want to yeah, I'm gonna go ahead and I'm not going to print this now. Okay, because I don't need to have that printing. And so what I'm going to do now is I've done the ifconfig. I just need to capture the server IP, and the server IP is going to be equal to that Wi-Fi info. And which one was it? It was the 0th element. And so now I've got my own server IP in the variable name server IP. Now we need to set up a server port, and that can be 2222. You can use different ones, but it's just your client and your server need to be using the same one. Now we're going to be sending packets back and forth. How big do we want that to be? The buffer size should be something like 1024. That's a nice big 1024 bytes, plenty for anything we would want to be sending back and forth. Okay, now I'm connected to Wi-Fi. Now I need to create my UDP server. I need to actually create the server. So I'm going to create an object UDP server, and that's equal to socket that I imported the library.socket, the method socket.socket. And now again, this isn't very interesting, just know that these work. So it's going to be socket.af_inet like that, and then comma socket.sock underscore DGDGRAM like that. Okay, and you can see that. And if you do that, that will create a UDP socket that you can talk over, and that will work great. Okay, and now what we've got to do is UDP Server dot, we've got to connect that object to, we've got to connect that object to a specific IP address. So what I'm going to do is I'm going to bind that server that I just created, and then what do I want to bind it to? The tuple. So you got to have two open parentheses, the server IP that we just got above, and the server port, which we just set above, like that. Okay, now we should be up and ready to go. So what is really useful at this point is if over here we display that information on the OLED, so that if you're running completely remotely, all you've got to do is look at your little OLED screen and you can know what your Raspberry Pi Pico W's IP address is, what its server IP address is. Okay, so that's something very useful to know, and you don't want to just print it out here on your PC. You want it to show up out by the Raspberry Pi Pico W. So what do we want to do? We want to do a display, dsp.text, and then what do we want to display? We want to display the string IP colon space, saying that this is our IP address, and then we want to concatenate that with the string value of what? Wi-Fi info. And I think that we already set that to server IP, so we could just say server IP like that. Okay, close the string. Okay, close the string. And then I'm going to put it at X value pixel 0 and 0. So the upper left there. Okay, and remember we already cleared the buffer, we already cleared the screen, and so this should go on fresh, and it should show me my IP address and on the OLED screen. Okay, and then what I also want to do is I also want to come down, and then I'm going to say dsp.text, and then what I'm going to show is the port like that, colon space, and then I'm going to concatenate that with the string value of server port. Okay, and that is going to be an X value of pixels of 0, so it's going to be in the 0 column. All right, and it's going to be in the 0 column, and then it's going to be the next line, which would be about 16 pixels down. So the Y value is 16 pixels down. That should be the next. The next line. All right, now we need to know, for that to work, I need to do a dsp.show like that. Okay, like that. And now let's see if that works. This should this time not just get an IP address, but it should show it over here. All right, so let's come in. I'm going to run it and let's see what happens. Okay, let's hope this thing, look at that, boom. So you see it got, and this time it connected so quickly because I guess it was still kind of maybe remembered from earlier, so it connected so quickly that we didn't even see the wait and the count, and you can see that we are connected to IP address. Now that is very strange, IP. You know what? This is probably good that that happened. It says 192.168.88.1. Now, why did that happen? What I suspect happened is, I suspect that I probably went off the screen. And that would be a very dangerous mistake to make. And in fact, I didn't do it on purpose, but it's probably a good thing that that happened. And let's make sure that that server IP was position 0. All right, and you see I would be sitting there trying to make it work on 192.168.88.1, not knowing that the 0 was off the screen. So let's try that again, and we're going to come in and run it. Boom, there it is. Okay, so also you could see, like, man, you might kind of want to take the IP colon out, because I could have 168.168.101 and I would still be going off the side of the screen. So you want to make sure that you can get that whole IP address on that line. But for me, I'm going to leave it like that. Okay, so now we are connected. We have an IP address. We've shown it. So now we are ready to really get going. So what I'm going to do is I'm going to create my main loop while true. When it's true, true, true is always true. Created an infinite loop, and now I want to display. And we're going to do this every time inside the loop. Why are we doing it again inside the loop? Because we're going to clear it at the end of the loop, and so we've got to do it here. And I think it's going to be exactly what we did up here. So we'll just snag that text and copy it. Really, you don't have to do it outside it, but I'll just leave it there in case I need it for debugging purposes. Tab that over. Okay, so we're going to do that display we just did. We're going to do it inside the loop this time. And now we're going to do I don't think I need to show it here, but now I need to, okay, I'm set up. I am the server. What does the server do? It sits and it waits for a command. And so I'm going to try to read a command at the, and I'm going to read the address. I'm not sending an address. I'm looking for a command. What do you want and who are you? What's your command and who are you? And so I'm going to read in command and address, and then I'm going to read from where? The UDP server that I just set up, and then receive from, and then buffer size. Okay, now this is a little disconcerting again, because you're saying receive from who? Receive from whoever asked, because that client is going to hit that socket. That client is going to hit the server, and that client is going to tell you who he is, his address, and his IP address, and he's going to tell you what he wants. And so you're sitting here waiting for a command from who? Whoever sends the command. Okay, so you're not listening for a client. So any client can connect to you. All they got to know is they got to know your IP address. Okay, hopefully that makes sense. And I know I explained that ad nauseum last time, but I just want to make sure that it starts making sense to you. So I'm going to just sit there, and then what I am going to do is, I think I'm just going to try to go ahead and print that out. So now I'm going to say display text, and then I'm going to say message received, like that. Okay, colon space in that string, and then I'm going to go 0 on X, 0 over on X, and then I'm going to go down to the next row, which would be about 36, I think. 36 pixels down should be like the third row, something like that, I think. And then I am going to display the text, and I want to display the what? I want to display the command that I just got, but if I'm going to display it, I need to you know what I'm going to do? I'm just going to make it a little simpler. I get the command here. I've read in the command. Now I need to decode the command. So I'm going to say cmd decoded is equal to cmd.decode, like that. Okay, and then I'm going to use the UTF-8, which is just kind of a standard format for text. And I think that's going to be good. Now, what do I display? I just display the string value of the command decoded, like that. And then where am I going to put it? I think I jumped too far. The message received doesn't need to go to 36, right? It should, I think 13 times 2, 13, 13, 26 should be far enough down to be the next row. So first one's 16, and then the next one is 26, and I think that will work. And then this one, the command then would be, I want to indent it, so I go 16 pixels over and I go 36 pixels down from the upper left corner, and then this should be like the fourth row. Okay, and now let's just do one more. Let me display dot text. So who is speaking to me? Well, I got that message from who? Who did I get that message from? I will put that on the next row, and then this would be kind of 46, and it looks like I went from 36 to 46, like 26, 36, 46. Sort of if you leave 10 pixels, it's enough to get rows of text on, I believe I have found. Okay, and now I'm going to display text. And who sent me that message? Well, it was, who sent me that message? Well, I'm going to take the string value of address, which it sent me, of 0, like that, and then like that. And now I'm going to indent over 16, and then I'm going to go 56 down. So again, it's like 16, 26, 36, 46, 56. I'm coming down kind of 10 pixels at a time, and that should be enough for a row. All right, now where does it, who did I get the message from? Well, when he sent me the command, he sent me his address with it. So the client, when he talks to me, he says what he wants, and he sends his IP address. So here I can see who am I, right? Who am I? And then who asked me for something. Does that make sense? Let's see if this works. If I'm going too fast, go back and watch last week's lesson. So now I'm going to run the program again. Okay, now it's not doing anything. Why is it not doing anything? It's sitting and it's waiting for a client to ask for something. So I really guess I'm going to jump over and I'm going to start working on the client program so that we can kind of make sure that they're talking to each other before we go too much further. Does that make sense? I hope it does. So I'm going to come on over here and I'm going to write the client program. So we need to import socket because the client talks through to the server over a socket. And now I've got to tell it the server address. I'm the client over here. I've got some random IP address. I don't put my PC IP address. I put the IP address of the server, the IP address of the Raspberry Pi Pico W, the IP address of who I want to talk to. And that was, do you remember, for me, that was 192.168.88.10. But you need to get that. You don't use my IP address, you use whatever you got over here on the server side. Does that make sense? I hope it does. Okay, so I get that. And then also I need to give it the port 2222. We agreed to talk on 2222. And now what did we also agree on? The buffer size needs to match, and we set that at 1024. Okay? Now, what do we talk over? A socket. So I need to create that, but this time I am going to be not a server, I'm going to be a UDP client. So I create a client object, and that's equal to socket.socket, like we did before, and then AF underscore INET, like that, and it should be socket before that, socket dot, like that, and then comma, and then we need to do a socket dot sock underscore DGRAM. Okay, and is that kind of like the same thing that we did over here? Yeah, it looks like pretty much the same thing, and the only difference is this time I'm creating a client instead of creating a server. All right, but that command looks the same to me. All right, so I've got the client created, and now what do I need to do? All right, I need to say while. Now you say, well, why aren't you going in and creating a Wi-Fi object, you know, on your client? Why aren't you going in and creating a Wi-Fi object and logging on and connecting? Because you're on your PC here, man. Your PC is already connected. So in Python, you're just using what's already been connected. You don't have to go and connect to the internet from Python because your PC is already connected. So it's a lot easier on the client side. So we say while true when it's true. True is always true. We're creating an infinite loop. Now we need to get the command from the user. So I'm going to say input, and we say, what is your color? Question mark space, like that, colon, close it. So we're getting what color from the user, and then we're going to encode it. So I'm going to say cmd encode is equal to cmd dot encode the method. And then how do we want to encode it? We want to encode it using the UTF-8 as we agreed to earlier, like that. Okay, does that look good? And now we're going to send it. So we're going to do UDP client that we just created dot send to. And who do we want to send it to? Well, we want to send what? CMD encoded, like that. We want to send CMD encoded. Let me get out of your way. We want to send CMD encoded, and then who to? Server address. All right, so you see, this is the server address. We set it up here, and we would probably do a whole lot better with an equal sign there. All right, I'm glad I looked. And then we're going to send to that server address the command that was entered by the user. Okay, the command that was entered by the user, we're going to send over to our server. And then I think with that, we might be able to get this thing to run. Okay, and so I'm going to come over here and I'm going to stop it. Okay, and so that has stopped, and now I'm going to run it. Okay, and when I run it, it looks like it's going to be happy, no errors so far. Okay, and if I come over here and just check, what do we see? We see that it's got its IP address, it's got its port, so that's working. And so now what I want to do is I want to run here, and it says, what is your color? And I am going to say red, like that. And then, what does it do? It crashes. Command encoded, what is that? Is not defined in line 8. What is that nonsense? Command encoded. Command encoded, like that. Let me try it again. Okay, what is your color? Red. Okay, and server address. What is wrong with that? Server AD, ADD, ADD, ADD. Am I spelling address right? Does address have one or two? I swear I can't spell. It does have two D's. All right, so we'll spell it that way, address. All right, so now we'll come over here and let's run that. What is your color? Red. Okay. All right, so that sent it. Now, did this get it over here? Okay, that did not show up down there. So let's see what I did. So command decoded over here. It's not showing up as I would like. It's not showing up here. So now we got to figure out why it is not showing up here. Well, one possibility would be that we didn't. One possibility of why it didn't show up is we did all this wonderful stuff, but we did not do dsp.show. How many times am I going to make that error? And that is a hard one to find sometimes. So I'm going to stop the program, and just for good measure, I'm going to stop the server. I will run the server again, and then I'm watching the little screen, and I'm sorry. I'm going to stop this. I'm going to stop the server, stop the client. We're going to start by running the server. I got in a hurry. Okay, the server is running, And we come over here and look and see, is the server running? Yep, it's got its IP address and its port. So the server is running. And so now we are ready to run the client. And it says, what is your color? And we will say red, like that. And then I will say enter. And still, it is not showing up here. So are we getting it over here? So I've got command address, and then UDP server receive from buffer size, command decoded, okay, and then it is not showing up over on my screen. So let's just see if we can print it, right? Let's just see if we can print it. Print CMD. I'll do it after the command decoded. So we will say let's print CMD decoded, like that. And that way we can see maybe I did something wrong with the display, or is it just not reading it? So let's try this. So we're going to stop the server. We're going to stop the client. We are going to run the server. Okay, the server seems happy. The server seems like it's up and waiting. So I will come over here and now I'm going to run the client and I will say red, like that. Okay, and now I've got a print. So if this comes in, it should print. Okay, so it isn't getting that back. So I'm going to try to unplug this. Like I say, sometimes in these cases, it's just good to unplug it. And I will start again. And now we are going to run the server. Okay, the server is connected. And now I'm going to run the client. Okay, boom. So what did we have? We had this problem of, again, it was just not getting connected. But you see now I sent the command red and it got the command red. I didn't change any code. It was just sometimes you got to reconnect. Okay, so I'm going to stop the server and I'm going to stop the client. And now what I think I will do is over here on the client side, I've got, I sent it, and now what I'm going to do is I'm going to wait for a response. So I sent a command to the server, and then I'm going to wait, and the server is going to tell me that it got that command. So I'm going to read back from that server some data, and then I'm going to read the address, and then it's going to come from who? UDP client dot receive from and buffer size. Okay, and who is it going to receive from? It is going to receive from whatever server I sent to. Okay, so let's look. I sent to the server address, and so then this is then automatically associated with that IP address, and then it's just going to automatically read from whoever I sent the message to, if that makes sense. So at this point, I should have data, and so what I can do is I can say data decoded is equal to data.decode. And then what am I going to decode? I am going to decode it using UTF-8, like that. Okay, and now I've got the decoded data. Now what I'm going to do is I'm going to come over and I'm just going to print here on my client. I'm going to say there was a message from server, and the message from server is going to be data.decode or data decoded, like that. Okay, so let's see over here. Now I got the command. Now I need to send the command back. I need to send the command back. So it's just like if Joe asks for red, then the server is going to tell Joe, yep, I got your red command. Or if Susie asks for blue, Susie's going to get back, yeah, I got your blue command. So just to kind of confirm that the command was received. And so that will be over here on the server side. And so what I will do is I will say data string is equal to received your command, colon space, okay, and then what I want to add to that is cmd dot decoded. All right, and so that should be the data string that I've created. Now I've got to encode that data string. Like that is equal to data string.encode. So every time before you send it, you encode it, and after you get it, you decode it. But we're encoding it here, and always this UTF-8. Close the quote, close that. So now I've got a packet ready to send, and then UDP server.send to, and then what am I going to send? Data string encoded, and then who to? The address, and that is whoever asked for it, right? Whoever asked for it up here, I'm going to send it right back to them with this annotation of received your command. Okay? Does that make sense? Send to. All right, so now kill this, and now I'm going to run this. Okay, I've got my IP address there over on the screen, and now I'll run the client. Okay, what color do you want? I want red. All right, and then over here I see red. That's good. And look at this. It's telling me I got a message from the server. What was the message? Receive your command, red. What color do you want? Blue. Okay, and then blue shows up over here. So you see I'm going back and forth. So now we got that framework all set up, and it's kind of doing right what we want. And then also remember over here what you can see, message received, okay, and you see how this is messed up. It's writing over each other. And so what I got to do is over here on the server side, after I do this show, let's go ahead and clear it. Now it won't immediately disappear, it'll stay there, but I'm going to go ahead and clear the buffer for the next time around. So I'm going to say dsp.fill and then 0 like that. And so that way, as I go through the loop, it's not overriding text on top of text. So we are going to kill the server, we're going to kill the client, we're going to come in and we're going to run the server. Okay, I see the IP address coming up over there. And so now I'm going to run here. What is your color? Red. All right. And then I've got red show up here. And now if I come over here, you see I've got message received red from 192.168.88.100, which is my desktop PC, which is acting as the client. Now I'm going to go ahead and on my client, I'm going to type in blue like that. And then you see message received blue, green, green. So, okay, you see, talking back and forth. All right, guys, we are almost there. This is really going very, very well. I'll come back up here a little bit. Too big. All right, now we got all of our protocols in place. What do we just need to do now? Now we just got to get the LED to do what we want. And that, my friend, is going to be pretty easy. So what I'm going to do is I'm going to come up and I am going to write, I've now got this decoded command, which is the color, and that's really all I need. So I'm going to say if cmd decoded dot lower, so I convert everything to lowercase, if that's equal to red, like that, then what am I going to do? Don't forget that colon, man. I did a parenthesis instead of a colon. Okay, so red LED dot value, I'm going to set to 1. Okay, and then green LED dot value, I'm going to set to 0. And then blue LED dot value, I'm going to set to 0. And why do you set those to 0? Because last time, if it was green, when you come to red, you got to turn green off, if that makes sense. Okay, so that looks good. And now we just need to do that kind of 3 times. So I'm going to get this whole mess. I'm going to copy it. I'm going to paste it. But then this time, instead of red, it is going to be green. And then the green value is going to go to 1. And the red value is going to go to 0, like that. And then one more time, we're going to say if the command decoded is blue, B-L-U-E, like that, then it is going to be not red, not green, and the blue value will be 1. Okay, we are going to try this now. And so what I'm going to do is I'm going to start by running the server. Okay, I will run the server, then we're going to come over and look and see. It's looking for an IP address. It's got its IP address. It's got its port. That is good. We're going to come over here and we are going to run the client. It's asking me for what color. That looks good. Now let me see if I can show you a view that shows you both of them. I will need to move out of your way a little bit more. Okay, and now what am I going to do? I'm going to ask for the color red, like that, and then I'm going to click enter, and then boom, look at that. All right, guys, giddy up. So what do we notice? We notice the LED turned red. We notice that it's got its own IP address, the server IP address. It sees that it received the message red from the client, and then it shows me here it responded back from the server to the client. It got the command and it turned it red. All right, so now I'm going to come in, and now instead of red behind my shoulder, I'm going to type in green. Okay, and then let's see what happens. And it didn't work there. Okay, why did it work one time and then not work a second time? Let me try stopping it. Okay, let me run it again. What is your color? Red. Ah, I see. Okay, let's come back over here. So why did it run one time, but it did not run a second time? Green LED isn't defined. Green LED. Okay, green LED. Okay, so now let's try run. Let's stop this. Let's run that. It's sure curious how it worked the first time, but then I guess it crashed when it saw that. Okay, so now that looks good. Now I'm going to come over here. I'm going to run the client. Okay, that looks good. Now we're going to come over here, and then I am going to say, what color do I want? I want red. Like that. Okay, boom, that worked. Now let's go green. And that turned off. Green, I see. I see what happened. And then I copied and pasted that mistake every time. So green, and then green. Let's run the server. Server is running. Let's run the client. Client is running, and so now I'm going to say red, and we'll switch over here to this view, Okay, so I'm going to type in red. Okay, boom, red. Now I'm going to type in green. I'm going to have to go munchkin mode here so you can see what I'm typing. Green, green, boom, blue, boom, red, green, blue. Giddy up. All right, man. And I hate being that small to show you my excitement. I'll come up here and show you my excitement again. Do you see how cool this is? Not only is it doing something, Okay, but it's showing you the commands that it's receiving. It's showing you its own IP address. It's really doing a whole lot here. Now, the thing that you got to see, though, is you're probably not suitably impressed because you're sitting here, and just like always, you are connected. Just like always, you are connected through the USB. What you got to see, though, is you're not talking over the USB. You're talking over Wi-Fi. So now what we want to do is we want to go mobile completely, and we want to disconnect from this USB, and we want to run on battery. Well, what do we have to do? We have to make sure that when we hook the battery, I can't go run the program, right, because I'm not connected anymore. So what happens when you power up the Pico W? It runs the program called main.py, whatever that program is. And so what I need to do is I need to come over here back to my server. Okay, and remember my server was called my Pico RGB server. That's all fine and good, but now what we're going to do is we are going to save it on the Raspberry Pi Pico. I have to stop the server first, and then we are going to do a file save as Raspberry Pi Pico W, and we are going to save this as main.py, just like that. Now, if I do this correctly, yes, replace whatever was there. Okay, if I do this correctly, now when I come in and I plug the battery in, it should automatically what? It should automatically run main.py. Now this, my friend, is where the magic happens. So what we're going to do is we are going to disconnect. Now you see this thing is just floating in air. I'm not tethered to the desktop. I am not tethered to the PC. And what I just need is I need a little power. So I'm going to come in with this handy dandy LiPo battery in the kit and this little power charger from the Sunfounder kit. And then what we're going to do is we're going to plug it in 1, 2, 3, just like that. And then the batteries and nothing else you have to do, and this should power it up. Now it's kind of a little disconcerting that no lights come on, and it can take 5 or 6 seconds waiting. 1, 2, 3, boom, look at that. Guys, this is just completely free floating. Look at that. And what do I have? I have an IP address. Get this stinking cable out of the way. We don't need that cable. And let me back off a little bit so you can see here. You see this thing is operating completely on its own. It's connected to Wi-Fi. It has an IP address. Okay, do you see that? That is just absolutely pretty amazing. It's working totally on its own. Now, we come back over here. We don't need this server program anymore. All we need is the client program, and now I'm going to run the client program. It says, what color is your LED? Okay, what color is your LED? And I really hate how this is always behind me. What color is your LED? Now let's try red, like that. Boom, look at that. All right, do you see that? Look at that. Okay, this is up by itself. Okay, now what do? I can say blue. And boom, it goes to blue. Is this not absolutely, positively amazing? No connections, just power. Green. Okay, and then notice how those things are changing. And so guys, I can't tell you what a huge step forward this is. We are operating completely remotely with a rechargeable battery. Now, how do you recharge the battery? If you want to recharge the battery, all you do is just come in and hook it to some suitable USB cord. But the USB cord then is only connected to charge the battery. You're not communicating with it over that. You're just using that to charge the battery. And now we have an absolutely, totally, completely remote system with a display and talking back and forth between this and our main PC. I am just extra, super, totally excited about this, as you can see. And so guys, what you can see is it's a pretty simple thing, like a pretty trivial little demonstration to control the RGB LED. But what's the important thing is we're operating on battery. so we're not tethered to a power supply. We're communicating over Wi-Fi, and we have a little mini display here. We have a little mini display here to show you some important parameters. So if you're remote, you can see some important parameters on this. You could control a stepper motor, you could control a servo, you could control like a door lock, a light, you could control anything from your main PC. And I think that is just absolutely spectacular. Okay, guys, this was a little bit of a tedious lesson, but if you enjoyed it, make sure to give us a thumbs up. If you haven't already, make sure you subscribe to the channel. When you subscribe, make sure you ring that bell so you'll get notifications when future lessons drop. And also, remember, it helps me with the old YouTube juice if you'll leave a comment down below. And I do want to give a shout out to you guys who are helping me out over at Patreon. Google has not been showing me a lot of love recently. YouTube has not been showing me a lot of love. And so you guys that are helping out with Patreon, you're really keeping me in the game here. So I want to give you guys a thank you for that. You guys that aren't, take a look down in the description if you want to. You can hop over to Patreon and hook a brother up. Okay, guys. Paul McWhorter with TopTechBoy.com. Make sure you share this video with other people because the world needs more people doing engineering and coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.